So in this Unit 5 part of the review, the first one talks about Kyle performs a transformation on a triangle. The resulting triangle is similar but not congruent to the original. Which transformation did Kyle perform? Well, this whole unit, Unit 5, we talked about similarity. So we have to look at our options. We have dilation, reflection, rotation, and translation. Right, this is a multiple choice question. It doesn't say anything about select all that apply. So to figure out which one of these is the right answer. Well, we just have to know which is the only transformation that creates similar figures. And that transformation is a dilation. Dilations make similar figures, and a dilation combined with the other transformation will always create similar figures. Reflections, rotations, and translations, if they are not done with a dilation, they'll always create congruent figures. Let's take a look at number 2. It says triangle ABC is reflected across the line y equals 2x. To form triangle RST, select all the true statements. Okay. Well, the only transformation we did was a reflection. And we just do a reflection. All we're doing is taking the original triangle ABC and flipping it over the line y equals 2x to get triangle RST. We just flipped it. We did not change the size. So ABC is the same exact triangle as RST. They're identical. They're the same exact size. They are the same exact shape. So that being said, if they're the same exact size and shape, their sides are going to be the same. They're corresponding sides. And I know they're corresponding because they're written in the same order in the statement. Okay. Well, if they're the same exact size, AB is not going to be 2 times whatever RS is. AB is not going to be twice the length of RS. That doesn't make sense. They're the same size. Also, if they're the same size, they're not going to be similar. They're going to be congruent. They're identical. Also, if they are the same, their angles, their corresponding angles will be the same. Okay? If the direction said we dilated the figure by a scale factor of 2, then yes, we would circle the second one, we would circle that one, and we would still circle the last one if it talked about doing a dilation. Okay? But it didn't. So the sides stay the same, the angles stay the same, and the triangles are congruent. If we take a look at the next one, I'm going to show you 2 ways you can do this. The first way is kind of the long-handed way. Then I'm going to show you how you can use it in Desmos to check your answer or even to figure out the answer. 3 says the equation of a line is shown, 8x minus 2y equals 3. A dilation created at the origin with a scale factor of 4 is applied to this line. What is the slope of the line after the dilation? And then B is what is the value of the y-intercept if the line after the dilation. So in order to figure out slope and y-intercepts, we have to first put this in y equals mx plus b form. Again, this is the long-handed way. So in order to put in y equals mx plus b form, we have to solve for y. So to get y by itself, I'm going to subtract the 8x. We get negative 2y equals negative 8x plus 3. They are not like terms. And then I'm going to divide by negative 2. Get y by itself. So when I do that, I get y equals negative 8 divided by negative 2 is positive 4. 3 divided by negative 2 is 1.5. When it's a nice decimal, write it as 1.5. If you've got like 0.3 repeating or 0.6 repeating, leave it as a fraction. If it's like 1.5, 2.75, something like that, write it as a decimal if you want to. So this is the equation of our original line, our pre-image. Okay? We want to know the slope of the new line after we did the dilation. And here's the thing, whenever we do a dilation, the slope stays the same. So the slope of the original line was 4. The slope of our new line is also going to be 4. The slope does not change. All the points on the line will change. All the points on the line are being multiplied by our scale factor by 4. So what we're going to do is take the y-intercept, which is negative 1.5, That is a point on the line. And we're going to multiply our y-intercept by the scale factor. And when we do that, 1 times negative 1.5 is negative 6. So the new y-intercept is negative 6, and our new slope is still 4. Okay, so this is how we can use Desmos on this particular problem. Right? This is how you can use Desmos, which is a lot easier, I think, and leaves less room for error. So if you don't want to solve for y, what you can do is take the original equation exactly how it's written and plug it into Desmos. Okay, we're going to plug it in as 8x minus 2y equals 3. And it will graph it for you. And you can get the two things we need. We need the slope and we need the y-intercept. Well, the y-intercept is really easy. If you click on the line and then click where the y-intercept is, there it is. It's negative 1.5 without having to do really any work. And then you repeat the same process. My y-intercept was 1.5. I multiply it by my scale factor. I get negative 6. Just like we did. But less work because you just look at the graph in Desmos. The slope is a little bit trickier. Whenever you're trying to find the slope of a line, look for those nice corner points. But when you look at your line, I don't see any corner points. And when I say corner points, I mean the line goes through the corners of the grid. I don't see any of those. Okay? So another way to flip to slope, you're always going to be given your y-intercept and your x-intercept. They highlight those nicely for you. So we can use our y-intercept and our x-intercept to do rise over run to find our slope. So if we look at our rise, my y-intercept is negative 1, so I went up 0.5, or 1.5, and my run, let's take a look at what my x-intercept is. My run, well, let me do that, sorry, click. My run from 0 to my x-intercept is 0.375. So the length of your y-intercept is your rise, your x-intercept over is your run, and when you divide that in your calculator, 1.5 divided by 0.375 is 4. Okay? So that's what we got. By just doing rise over run in Desmos, we got the same exact slope. So whichever way works for you, go for it. I think Desmos might be a little bit easier, and it makes less room for error. So for this one, we are given two circles, circle M and circle N are shown. Complete this statement to explain how it can be shown that the two circles are similar. And generally, like 99% of the time, when we try to map circles onto one another to show that they are similar, we do a translation, then a dilation. We're trying to get the centers to map up, and then we do a dilation. This scenario, they like to change things up on us, and they did a reflection and then a dilation. So still the same concept. You have to figure out which reflection works to get M to map to get the center of M to map onto the center of N, and then figure out the scale factor. So our options are a reflection over the x-axis, reflection over the y-axis, and then over the line y equals x. Well, the one that makes most sense here is the reflection over the x-axis, and you might have to guess and check, because that's the only one that will get the centers to map up, because M is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We got our centers to map up. And we reflected over the y-axis, M would have moved over here, 1, 2, 3, 4, 1, 2, 3, 4. That didn't work. And if we reflect over the line, y equals 1, the center is sitting on that line, so it wouldn't even move. It would stay right where it's at. So neither of those reflections would work. The only one that does is a reflection over the x-axis. Okay? So then after we reflect over the x-axis, we have to figure out what scale factor works. And when you're trying to figure out scale factors with circles, you look at the radius. So the radius of our original circle was 2. Okay? And our new circle is 1, 2, 3. So you have to figure out, well, what do I multiply 2 by to get 3? And you have to guess and check. So we look at our first one, 2 times 1.5, that gives me 3. That's my answer. 2 times 1 gives me 2, not my answer. And 2 times 0.67 does not give me 3, not my answer. Okay? So here you just kind of have to guess and check and figure out which one works. We take a look at the next one. Right? Number 5, it says triangle XYZ is shown. Which triangle must be similar to triangle XYZ? Well, in order for triangles to be similar, 2 angles have to be the same. And if I look, A is talking about 2 angles being the same. B is talking about 2 angles being the same. C is only talking about 1 angle being the same. And D is only talking about 1 angle being the same. So now, by just knowing that fact, we have a 50-50 shot at getting the right answer. Okay? To figure out what the angles are, you have to know all the angles of the triangle we were given. So we have to figure out, well, what's the measure of angle Y? Well, to do that, I know all the angles of a triangle add to 180, so I can subtract my given angles from 180, and that will give me my missing angle. So 180 minus 40 minus 100 is 40. Okay? So the one that matches is A, because the triangle we were given has 2 angles that equal 40 degrees, and A is talking about 2 angles being 40 degrees. B is not my answer because the triangle we were given doesn't have a 60-degree angle. So that one just doesn't work. Okay? After you watch this video, we are done with those examples. You can log on to Canvas and go to modules and Unit 5 and try the Unit 5 practice.